Now we're going to be talking about, we are moving a bit to further mathematics, and we're talking about matrices and determinants. And of course, we know that a matrix contains elements arranged in a rectangular array in brackets. And of course, you could be asked to find the determinant. This is an example of a matrix actually. We have 2, 3, 4, 5, 6, 7, 1, 2, 3. So this is an example of a matrix, and determinant converts a matrix into a scalar, that is a single value. So I'm going to focus now on determinants. So how do we find determinants? We are going to be noting that determinants can only be found for, or you only be asked to find determinant for a square matrix, that is 2 by 2 matrix, 3 by 3 matrix, 4 by 4 matrix. But at this level, you focus on 2 by 2 and 3 by 3 matrix. So let's now go to, for example, we have a matrix A is equal to, we have something like 1, 2, 3, 4. Now they can say find the determinant of A, or they can simply say find A and they enclose it in 2 strokes. If it's written like this, it's telling you to find determinant. Or sometimes they can simply say find, and they'll put solve something like this, and they put 1, 2, 3, 4. So if a matrix is enclosed in 2 strokes instead of in a bracket, it's a way of telling you find determinants. They can say find the determinant of A, or they can simply say find A and they put it in 2 strokes. No, they're asking you to find determinant. So let's see the formula, so to speak, of how to find determinant of a matrix. So let's start with a 2 by 2 matrix. So first of all, you can either put your sign plus here and minus here, or you can put it plus here and minus here. That's the first thing to do. Then we have 2 diagonals. The first diagonal here is called the leading diagonal, and of course this other diagonal is the second diagonal. So you multiply the elements in the leading diagonal, that is A times D. Of course that always goes with plus. Now this one goes with minus, minus. Multiply the other element in the second diagonal, that's B times C. So that's the formula we use when we are finding the determinant of a 2 by 2 matrix. Now what about for a 3 by 3 matrix? Now this time it becomes a bit deeper. So for a 3 by 3 matrix, you can do it in 2 ways. So I'm going to explain the 2 ways. The first way is either you use the first row or you use the element of the first column. So let me focus on the element of the first row. Of course, this will be plus, this will be minus, and this will be plus. So this will be equal to, you pick the element in the first place, A. Of course, it goes with a plus. You're going to bring out a 2 by 2 matrix. You pick this one minus. You pick the element in the second one, that's B, times a 2 by 2 matrix. Then plus, you pick the element in the third one, C, times a 2 by 2 matrix. Now, what's the 2 by 2 matrix you use for A? Since you have picked A, you will exclude the elements here, exclude the elements here, the elements of the same row and the same column. That means the 2 by 2 matrix A is going to multiply is E, F, H, I. Now, if you are picking B, you exclude this, and of course, you exclude the one where we have B. So that means we are left with D, G, F, I. And if you are picking C, you exclude the row and column C belongs to. That makes it what? D, E, and what? G, H. Then you repeat the same process for a 2 by 2. So this is going to be your plus minus, your plus minus, your plus minus. So this diagonal times this diagonal times this diagonal, and of course this diagonal times this diagonal. So in this case, it's going to be A multiplying the product of what? E times I minus F times H, minus B multiplying the product of D times I minus F times G, and plus C multiplying the product of what? D times H minus E times G. So that's when you use the rule. What about if I decide to say I want to use the column now? If I want to use the column, so it's still going to give you the same answer, it's just another way you can make a choice. So plus, minus, plus. So you pick A, is going to multiply a 2 by 2 matrix. Now this is minus. You pick B, is going to multiply a 2 by 2 matrix, and of course plus. You pick G, is going to multiply a 2 by 2 matrix. So if I'm picking A, I will exclude the row and I will exclude the column. So it's going to be what? E, F, and what? H, I. If I'm picking that's D, I will exclude the row and the column. So it's going to be what? B, C, and what? H, I. And of course, if I'm picking G, I will exclude the row and the column. So it's going to be B, C, and what? E, F. So we'll repeat the same process: plus, minus, plus, minus, plus, minus. So this diagonal with the plus, this diagonal with the minus, this diagonal with the plus, this diagonal with the minus, this diagonal with the plus, this diagonal with the minus. So it's now going to be equal to A times E times I minus F times H. Of course, subtracting D, now it's going to multiply this diagonal B times I minus H times C times H, and plus G will multiply this diagonal B times F, then the diagonal with minus C times E. So these are two ways you can do for a 3 by 3 matrix, and this is the way you can do for a 2 by 2 matrix. So that's, at the end of the day, you will have a single value, which is a scalar. So you would have found your determinant, you would have converted the whole matrix into a determinant, into a scalar. So in the next question, we will now take a real example of how we can either solve for a 2 by 2 or a 3 by 3 matrix from a past question. Thank you.